You are asked to design an API server, and you have to choose between REST, GraphQL, gRPC, and WebSockets. How can you actually make the right decision for your project? In this video, we'll break down every major API architecture and the history behind it, what the actual payload looks like on the wire, and the specific engineering trade-offs so you can make the right call for the project. Let's start at the very beginning, long before the modern web existed. Back in the 80s and 90s, the goal for distributed computing was pretty straightforward. Make calling a remote server feel exactly like running a local function. That gave us RPC, Remote Procedure Call. RPC is built around action. Instead of asking for a document or a resource, you're calling a function on another machine and expecting it to behave almost like a local one. As enterprise software grew, companies started caring more about security, reliability, and a strict contract between systems. And that's where SOAP comes in during late 90s, the Simple Object Access Protocol. SOAP is incredibly reliable, which is why banks, governments, and other enterprise systems adopted it. The downside is that every request carries a lot of XML around with it, so even simple operations end up sending too much information compared to what they need. Today, the same RPC idea lives on in gRPC. Google redesigned it from ground up, replacing the bulky XML with protocol buffers, a compact binary format that's much faster to serialize and transmit. So where does gRPC really shine? It's incredibly fast, strongly typed, and it's a great fit for microservices talking inside the same infrastructure. The trade-off is that the client and server becomes more tightly coupled, and because everything is binary, inspecting requests is not as easy as opening them in a browser tab. Around the year 2000, the web was growing at an incredible pace, and SOAP was starting to feel far too heavy for most applications. That's when Roy Fielding introduced REST. REST didn't invent the new protocol. It simply embraced HTTP. Instead of calling functions, you work with resources using familiar HTTP methods like GET, POST, PUT, and more. Because REST is stateless and follows the standard HTTP conventions, caches, proxies, and all browsers know how to work with it. That simplicity is the biggest reason it became such a hit for the public APIs. But REST has its own limitations, one of the biggest being overfetching. Imagine your app only needs user's name. The API might still return email addresses, profile pictures, timestamps, preferences, and a bunch of more fields that your client doesn't actually need. And then there is the underfetching. Say that your application needs to get the user's orders. For that, you need another endpoint, another request, another round trip across the network before your page has everything it needs. REST is simple, well understood, and works extremely well for most APIs, but fixed endpoints mean you'll often need to download more data than you need, or make several requests to get enough data. That pain actually led to GraphQL. Around 2012, Facebook was investing heavily in mobile. Connections were slower back then, and every unnecessary byte mattered. They wanted clients to ask for exactly the data that they needed, nothing less and nothing more. The result was GraphQL. Instead of exposing lots of different endpoints, you typically send every request to a single endpoint. The client describes the exact field it wants, and the server returns the data in precisely that shape. That means there is no overfetching and far less underfetching. A single query can retrieve related data from several sources without forcing the client to make multiple network requests. For front-end developers, that's a huge advantage. But of course, someone still has to assemble all the data behind the scenes. Complex queries can introduce problems like N+1 database lookups, and because everything flows through one endpoint, traditional HTTP caching becomes much harder. RPC, REST, and GraphQL all share one basic idea. The client asks and the server answers. But that model breaks down for things like chat apps, live stock prices, or sport scores. Constantly polling the server every second just isn't sufficient. That's where we have our next star, WebSockets. The connection starts as an HTTP request, but then it's upgraded into a persistent two-way communication channel. Once that's established, either side can send data whenever it needs to. The result is true real-time communication with very low latency. The trade-off is that keeping millions of connections is not cheap, so scaling and load balancing becomes much more challenging. But after all of that, which one should you choose for your next project? Here's a simple way to think about it. Need fast communication between internal microservices? Go for gRPC. Building a public API for other developers? REST is probably the safest bet. Working on data-heavy frontend and a mobile app where every request matters? GraphQL is your friend. And if your application needs live updates like chat, multiplayer games, or trading platforms, WebSockets are the best tool for you. In practice though, you'll often combine these technologies instead of picking just one. A chat application, for example, might use REST to load your conversations when your app opens, and then switch to WebSockets to receive new messages instantly. That's really the main takeaway here. There isn't a single best API architecture so you can use it every time. Every option solves a different problem, and everyone comes with different trade-offs. So instead of choosing the newest or the most trendiest, just pick the one that works for your project and for your need. If this video helped you, consider subscribing, and I'll see you in the next one.